Inside this compact engine, a continuous rotational motion drives a piston through thousands of cycles every minute. A simple mechanism, built to operate at remarkable speed. Its operation depends on one of the most fundamental mechanisms in mechanical engineering, the slider crank mechanism. The crankshaft rotates continuously, but the piston must move along a straight path inside the cylinder. Between them, the connecting rod transfers force while constantly changing its angle. The motion appears simple, but neither piston speed nor piston acceleration remains constant during a revolution. Near the ends of its stroke, the piston slows, changes direction, and accelerates again. These continuous changes in velocity generate inertia forces, vibration, friction, and heat. At high engine speeds, small changes in geometry, mass, lubrication, and balance can have a major effect on durability. To understand the mechanism more clearly, we can separate the engine into its individual components. As the assembly opens, the structure behind the motion becomes visible: the cylinder and housing, the piston and connecting rod, the crankshaft, bearings, covers, and supporting components. Each part has a different role, but their geometry must work together as a single mechanical system. During assembly, the relationship between these components becomes even clearer. The crankshaft is supported inside the housing. The connecting rod links rotational motion to the piston. The cylinder constrains the piston to a linear path. Once assembled, separate components become one continuous mechanism. Rotation becomes reciprocating motion. Combustion becomes mechanical work. And a compact arrangement of simple components becomes an engine capable of operating thousands of times every minute. This is mechanical engineering in motion.